Hello, this is Step School. If you want to master robotics and programming the microcontrollers, please subscribe to my channel. In this video, I want to show how to communicate with the IMU sensor through SPI protocol. First, we have to configure SPI using CubeMix tool. So we're gonna open this IOC file. Then we open connectivity and I will work SPI. But on my board, one of the SPI pins are configured as output pin, so I'm going to reset it, and I will enable SPI by choosing full duplex master mode. Then we have these 3 pins: clock, MUSO, and MOSI lines. And as a data size, I will choose 8 bits. Then as a prescaler, I will put 32. And also clock polarity high and clock phase second edge. And also we need an additional pin for chip select line to activate and deactivate the IMU sensor. So I will use PA4. So we choose GPA output and we can enter a user label. Then we can save the file. After the configuration of the SPI protocol, we can start reading the IMU data. But I wrote some additional code to sample the data every 1 millisecond. For that purpose, I'm using timer update interrupt. You can refer to my previous video to understand how it works. So basically every 1 millisecond this callback function is called, and within this function I set the value of this variable. And pay attention to the keyword volatile, and again you can refer to my another video to understand this keyword. Then within the while loop I check the value of this variable, so when this variable is non-zero I will execute some code. In other words, in every 1 millisecond I execute the code within this if statement. Let's move on and read the IMU sensor. For that purpose, of course, we have to work with the register map and the datasheet of the IMU sensor. Starting from register 59, we have the accelerometer, temperature, and the gyroscope measurements. So I'm going to read all these 14 bytes starting from register 59. So the onset register address is 59. To read IMU sensor using SPI interface, first we have to set chip select line low. And of course, don't forget to connect chip select pin to the IMU sensor. In my case, I have to connect PA4 to the chip select pin of the IMU sensor. After setting low, we have to specify the address of the onset register. In my case, I have to send 59 because I'm going to read starting from register 59. In addition, we have to indicate read or write operation. So when sending the address, in our case 59, we have to set the most significant bit indicating the read operation. Then we can receive data from the IMU sensor. In other words, we will receive 14 bytes. So I wrote this function to read the IMU sensor. It has 3 parameters. The first parameter is to specify the onset register. Then we have the buffer where to store the data. And also we specify the length, the number of register we want to read. And as I told you, when sending the register address, we have to set the most significant bit indicating read operation. That's why we need this or bitwise operation. Then I reset chip select pin. Then I transmit this data, the address, and also I indicate the read operation. Then I receive a data and I will store it within this buffer. And of course we have this argument to specify the length. Then I set chip select pin to deactivate the IMU sensor. I also declared this function at the beginning to use it within the main function. Next, I defined two variables. One variable, I call it accelerometer data. So it has this argument. Also, I have this argument to read all 14 bytes. Then within this if statement, I read the IMU sensor, starting from register 59, as you remember, and I store it within this buffer, and also I specify the length. I also have to encapsulate these 2 bytes to get the accelerometer data. So if you open the reference manual, register 59 holds high byte of the accelerometer x-axis data. Then we have register 60, which holds low byte of the accelerometer x-axis data. So each axis measurements possess 2 bytes. So we need to merge these 2 bytes to get the proper data. So we have to shift first this byte by 8 bits, then I add this next byte. If you want to get y-axis, for instance, you have to do the similar operation. So instead of 0, we have 2, and instead of IMU data 1, we have IMU data 3. So this operation gives y-axis accelerometer data. Then we get z-axis, then we have temperature, then we can get gyroscope and other things. And also we have to reset this timer flag to execute this code every 1 millisecond. Next, we can debug our code. Then we can use timeline graph to visualize our data. So we have the accelerometer data, the name of the variable. We need to write it here. And again, you can refer to my another video to understand how to set up serial wire viewer. Next step, I'm going to run the code. And by moving the IMU sensor, we can clearly see how the data is changing. If I align x-axis with the gravity, we get this value, minus 16,000, roughly speaking. But if I put up in opposite direction, we get around plus 16,000. This is because of the full range of the accelerometer. So next, I'm going to show how to configure this parameter by sending data to the IMU sensor. So let's transmit data to the IMU sensor to select different full-scale range. On the register map, we can find this register, which is called accelerometer configuration. We can use this register to select full-scale range. So by default, we have this value. That's why we get around 16,000 when we align the x-axis with the gravity, because 16,000 is around the half of the maximum value. To send data to the IMU sensor, first we have to set chip select line low to activate the IMU sensor. Then we send the register address to which we want to write data. In our case, we send 28, and the most significant bit has to be 0 because we want to do write operation. Then we send the value of this register. In our case, we have to set these bits to 0, 1, but other bits we keep them 0. So I defined this function to write to the specific register. So it has 2 arguments, the register and data. So this data will be written to this register. First, we have to reset chip select line to activate the IMU sensor. Then we transmit the register. Then we transmit data. Then we deactivate the IMU sensor by setting chip select line high. Also, we have to declare this function. And next, I'm going to use this function to set the full scale range to 4G. So we have this register, as you might remember, register 28, and we need to set these 2 bits to 01. So we have 01. So I wrote a binary number, or we can write a hex number as well. Finally, we can debug the code. Then we can resume the code. And if we align the x-axis with the gravity, we get minus 8,000, not minus 16,000. So if we rotate to 180 degrees, we have 8,000, not 16,000. So we successfully configured the full scale range by sending data to the IMU sensor through SPI protocol. We successfully used the SPI protocol to get the IMU data. However, there is much room for the improvement. First, we used the simple SPI functions, but instead of this, we could use interrupts or direct memory access to optimize our code. Also, there is a magnetometer inside of this IMU sensor. However, we cannot read the magnetometer measurements as we read accelerometer, temperature, and the gyroscope measurements. We have to configure the IMU sensor further to get an access to the magnetometer readings. Therefore, you can refer to my course on my website to get more exhaustive information about this sensor. Also, I will cover other communication protocols, including I2C, UART communication protocol. Also, we will learn how to work with interrupts and the DMA. And finally, I will explain to you Euler angles, complementary filter, and the quaternions to estimate the orientation using the IMU sensor.